Hello, this is Ms. Sirica. I am going to go through the chemical reactions PowerPoint with you for this chapter, chapter 11. Um, we're going to learn how to identify types of reactions and then predict the products when you only have the reactants. We are going to learn 5 different types. The first one is a synthesis reaction. A synthesis is a regular word where you synthesize something, you create it. The generic equation is an element plus an element that combines to make an ionic compound. So here calcium's an element, oxygen's an element. It happens to be diatomic because it's part of the Hun family, and when they're by themselves, they're diatomic. When you push them together, you put calcium with oxygen, you check the charge, and if it's +2, -2, you do not carry a 2 over from the other side because +2, -2 is neutral without a subscript. You then can balance the equation by putting a 2 in front of the calcium oxide and a 2 in front of the calcium. A good analogy for this is if Brennan goes to the dance by himself and so does Sally, but by the end of the evening, they are a new couple. That is a good analogy because we have a single plus a single combines to a couple. Okay, maybe that'll help you remember a synthesis reaction. Here's some examples of synthesis reactions. You can see you can identify the synthesis because it's an element plus an element. Element plus an element, even though it's diatomic, it's still just an element, not a compound. When you push the two together, you can't just have MgN, you can't have MgN2 because of the charges of Mg and N. +2 and -3, you have to cross the 3, cross the 2. So this is the correct formula for magnesium nitride. You have to write it like that, and then you can go back and balance it later. After that's correct, you put a 3 in front of the coefficient in front of magnesium. Sodium with chlorine becomes sodium chloride, +1, -1. Don't carry the 2 across because sodium chloride is neutral when there's no subscripts. Now you can balance it by putting a 2 in front of the NaCl to get 2 chlorine and then a 2 in front of the sodium. The next reaction is decomposition. Decomposition means to come apart. That's a regular word you should know. Think of a body that decomposes, it comes apart. So you identify that because there's only one reactant that's a compound, and it breaks into individual elements. So there could be 2, there could be 3. When you have to write them, there'll only be 2. But if you had to identify a decomposition, there might be multiple products, but still only one reactant. So the only thing it can do is come apart. A good analogy for this would be if Luke went to the dance with his girlfriend Stacy, and at the end of the night, he's decided that he does not want to date Stacy any longer. So they are now separated. So we took the compound, the couple AB, cation, anion, and separated them into individual elements. Here are some examples. They're already written. H2O decomposes if you apply electricity into the 2 elements, hydrogen and oxygen. It just so happens hydrogen and oxygen are diatomic, so we put those 2's on there, and then we balance the reaction with a 2 in front of water and a 2 in front of hydrogen. Mercury oxide decomposes into 2 elements. Check to see if any of those elements are part of the Hun family. If they are, you put a 2, and then you have to balance the reaction. 2 in front of mercury oxide and a 2 in front of mercury. Memorize the Hun family. Single replacement. So one element, a single element with a compound, switches places with a similar element. So if A is a metal, then it will bump out the metal in the compound and pair up with the nonmetal or the anion. For instance, if Ryan goes to the dance by himself and James is with Emma, then by the end of the night, they've done the switch and Ryan is now dating Emma and James is by himself. We know that was James' choice, I'm sure. So this is a good analogy because the single element and the couple, the single element, which is different, and then a couple. But we've still paired the boy with the girl and the boy with the girl, which is a cation, anion, cation, anion. Double replacement will be two ionic compounds, so it'll look much more complex. So we have a cation, cation, anion, and they do the switch. A good analogy would be Chip and Natalie go to the dance, and Stephen and Sarah go to the dance together. And by the end of the evening, they've decided that they prefer the other partner's company. So they did the switch where we pairing up still male with female, just like we would pair up cation with anion. That's why that's a good analogy. Let's look at some of those reactions. So I've color-coded them so that you can see with a cation that pairs up with the anion. So silver now pairs up with chloride, and then be careful that you always put the cation first and then the anion second. So sodium comes first, the metal, and then the non-metal. In this case, it's already balanced because everything's a +1 or a -1, but that's not always going to be the case. In this case, zinc pairs up with chloride, but zinc is a +2. To get to zinc's charge, you have to check the transition charge sheet, and chloride's -1, cross the 2 down. It has to be crossed down because that's what makes it neutral. And then you're left with hydrogen, which is a +1, and sulfide, a -2, so you have to cross the 2 down. And then balance. Sure. Oh, it's already balanced. Good. And then in this one, calcium pairs up with nitride, +2 -3, cross the charges, and then sodium pairs up with chloride. We know sodium chloride is a +1 -1. NaCl we should be familiar with. We never write sodium chloride as Na3Cl2. So you don't do that, you just go back later and balance with a coefficient. Lastly is combustion. This one's kind of a hard one to have an analogy for. So I just thought I'd throw in PJ and see we had that flame symbol during the Kahoot a whole bunch of times. He was on a roll. And so if you have a hydrocarbon, actually people are made of lots of hydrocarbons. Those are compounds that have hydrogen, carbon, and sometimes oxygen in them. When we want to combust something, we have to add oxygen. It always produces CO2 and H2O. Usually that H2O is a gas, but sometimes you can see it coming out of your tailpipe as a liquid. If it's cold out, it recondenses. Here are some examples. There's the generic. CH4 is a hydrocarbon. Notice that it's not ionic. It's not a metal with a nonmetal. It's all nonmetals. So you add oxygen to methane, it produces CO2 and H2O every time. Propane, C3H8, add oxygen, produce CO2 and H2O. Glucose happens to have an oxygen in it. It's still a hydrocarbon. Add oxygen, produce CO2 and H2O. All these will need to be balanced, but it's really, this is the generic equation. It's always oxygen producing CO2 and H2O every single time. You just have to identify the hydrocarbon. A common mistake would be that people think that this is single replacement because this is a single element. But if it's oxygen, it's not going to be single replacement. It's going to be combustion because this is not an ionic compound. Keep that in mind. All right, so real quick, how to identify the reactants. How to identify the type of reaction. Look at the reactants. E represents an element, C is a compound. So if you have two elements combined, that'll be synthesis. If you have a single compound, the only thing you can do is break it apart. If you have a single element and a compound, that's single replacement. If you have two ionic compounds, double replacement. And a hydrocarbon and oxygen is always combustion. Some examples. Let's predict. See if you can predict what this is. Two elements, synthesis. A single reactant, decomposition. Two ionic compounds, double. A single element and a compound, single replacement. So this is a little more complex. We've decided to take out the polyatomic ions since we're doing the homeschooling, and it'll just be monatomic cation and monatomic anion. But you should still be able to recognize that this is single replacement if you see it. Come on. This is a single compound that can only do one thing, and that's come apart. This is a single element, even though it's diatomic. Doesn't have to be the first thing. It can be the second substance, but it's still an element and a compound. This looks really complex. Cation, anion, double replacement. I think there's a few more. See if you can predict them before I click it. Double replacement, 2 compounds, only 1 compound. The only thing it can do is come apart. Single element and a compound, single replacement. Whoops, that went a little too fast. That's an element and an element. Push them together, make a new compound. A single element and a compound. A compound and a compound. Oh, one more. Compound and a compound. Another double. All right, this is the worksheet that you're going to work on. I only have part of it. You can only see part of it. You'll go to the link posted on wherever your teacher is posting it. First thing you'll do is a set of matching, so you know how to identify each of them, get it into your head yourself. And then this is an example of what you'll do that's on your worksheet. You'll have this example, Al2S3 yields Al plus S. You'll identify that as a decomposition because there's only one reactant here and it breaks apart. So that's decomposition, and then you go ahead and you balance them. These balancing should be really easy, really quick for you. The key is to predict the correct products. Compound plus a compound and they switch places is double replacement. Okay, well, good luck with this and let your teacher know if you need any help. Have a good night. How do I stop this? How do I stop this? Please tell me I was recording the whole time.